Hello viewers, in today's session we are going to discuss some very important problems based on quadratic equations. So let us take this problem. Here we are given if the sum of the roots of a quadratic equation is 3 and sum of their cubes is 72, then we have to find the equation, right? So let us start, and here we are given the sum of the roots of the quadratic equation is 3, right? So let us take the quadratic equation as x square minus sx plus p is equal to 0, right? Because this is the form of the quadratic equation when we are given the sum and product of the roots of the equation. So here s denotes the sum of the roots, and p denotes the product of the roots, right? So product of the roots. So if we take alpha and beta as the roots of the equation which is to be obtained, then s is alpha plus beta, and the product of the roots is given by alpha times beta, right? So whenever we are given the sum s and the product p, then any quadratic equation can be written in this form, that is x square minus sx plus p is equal to 0, right? And we already know that the standard form of a quadratic equation is ax square plus bx plus c is equal to 0, where a is not equal to 0, right? So let us first write the conditions here. So the sum of the roots of a quadratic equation is given as 3. So we are given alpha plus beta is equal to 3. So the sum is given here. So we have already given this sum s, and the sum of their cubes is 72, right? So we are also given alpha cube plus beta cube is equal to 72, right? So if we now take s is equal to 3 here, then the equation is x square minus 3x plus p is equal to 0. So it means that now we have to find the value of p, and p is our product of roots. So now let us make use of these two equations to find the value of p. And here we are given alpha plus beta is equal to 3 and alpha cube plus beta cube is equal to 72. Now here I will make use of an important algebraic identity, and the identity goes like this: x cube plus y cube is given as x plus y, and here we have x square minus xy plus y square, right? So replacing x and y by alpha and beta, we have alpha cube plus beta cube as alpha plus beta. Then we have alpha square minus alpha times beta plus beta square, that is equal to 72, right? Now this term alpha plus beta is given as 3, so here we'll write 3, and now we'll combine alpha square plus beta square together. So alpha square plus beta square, and here this alpha times beta may be replaced by p, right? So here we have p. So this is equal to 72. Now we can easily find out the value of alpha square plus beta square, because we know that alpha square plus beta square is given by alpha plus beta whole square, and then here we have minus 2 alpha beta, right? Now alpha plus beta square is given by 3 square, because alpha plus beta is 3, and here we have 2 times alpha beta. Alpha beta is our product of roots, so here we have p, right? So this is 9 minus 2p. So let us substitute the value of alpha square plus beta square over here. So we have 3 times, and here we have 9 minus 2p minus p is equal to 72. And now Now here we have 9 minus 2p, minus 2p minus p is minus 3p. Now dividing 72 by 3, we have 24, right? So now we have a linear equation in p. So 9 minus 3p is equal to 24. So minus 3p is given by 24 minus 9. So this is minus 3p, and 24 minus 9 is 15. So p is given by 15 over minus 3, that is minus 5, right? So now the value of the product of the roots, that is p, is minus 5, right? So now let us substitute this value of p in this equation. So now we have x square minus 3x plus p, and p is minus 5, right? So this is our desired quadratic equation, in which the sum of the roots of the quadratic equation is 3, and sum of the cubes of the roots is 72. So this is our desired quadratic equation. So now let us consider this problem. So here we are given if alpha and beta are the roots of the quadratic equation, Lx square plus mx plus n is equal to 0, then we have to find the equation, a quadratic equation whose roots are given by square root of alpha over beta and square root of beta over alpha, right? So here we are given the roots of this equation as alpha and beta, right? So we are given this equation, that is Lx square plus mx plus n is equal to 0, and its roots are alpha and beta. So now we have to find another quadratic equation whose roots are given by these two numbers, right? So let us suppose that the quadratic equation is x square minus sx plus p is equal to 0, and its roots are given by square root of alpha over beta, and here we have square root of beta over alpha, right? Where this s again denotes the sum of its roots, and the roots are given by these two numbers, and p is the product of these two roots, right? So s is the sum of these two numbers. So here we have square root of alpha over beta plus square root of beta over alpha, right? So let us simplify this term. So we have square root of alpha over square root of beta, then here we have square root of beta, and here we have square root of alpha. So separating the square root sign, so now we can take the LCM. Here we have square root of beta times square root of alpha, and now multiplying these two numbers, that is cross multiplying. So square root of alpha times square root of alpha is simply alpha, then square root of beta times square root of beta is simply beta, right? Because the square root get cancelled here, right? Okay, so now we can write alpha plus beta over square root of alpha times beta. So combining these two terms, right? So our s, which is the sum of the roots, that is the sum of these two numbers, is now alpha plus beta over square root of alpha times beta. Now alpha plus beta can be obtained from this quadratic equation, right? Because this quadratic equation has roots alpha and beta. So now alpha plus beta is the sum of the roots of this quadratic equation, and we know that alpha plus beta is given by minus b over a, where b is the coefficient of x and a is the coefficient of x square. So we have minus m over l, right? And similarly, Alpha times beta is the product of these two roots. So this is given by c over a, where c is the constant term and a is the coefficient of x square. So we have simply n over l, right? So substituting these values over here, we have now alpha plus beta is minus m over l, and here we have square root of n over l. So simplifying, we have minus m over l times taking this l to the numerator, we have square root of l over n. So now we have minus m, and here we can take this l inside the square root sign. So we have l over nl square. So now this l and this l get cancelled. So we have minus m over square root of n times l, right? So the value of s is given by this expression, right? Okay, now let us find out the value of this p. P is the product of these two roots. So we have p is equal to square root of alpha over beta times square root of beta over alpha. So this is square root of alpha over square root of beta, and here we have square root of beta over square root of alpha. So these two terms get cancelled. Here also these two terms get cancelled, and we are left with 1, right? So the product of roots is 1. So taking these values in this equation, the required quadratic equation is now given by x square minus s is minus m over square root of n times l. Here we have x and here we have 1, right? Now multiplying throughout by square root of n times l, we have square root of n l, and here we have x square, minus and minus multiplied together becomes plus, so we have plus mx, and here we have that is 1 times square root of n times l, right? And this is equal to 0. So this is our required quadratic equation. And here obviously n and l are not equal to 0, right? So l is not equal to 0 and l is also not equal to 0. Now let us solve this important equation. So here we have to solve for x, and the equation is given as square root of 1 plus x square plus square root of 1 minus x square divided by square root of 1 plus x square minus square root of 1 minus x square is equal to 5, right? So now we'll solve this equation with the help of an important concept that is known as componendo and dividendo, right? So let us first quickly see the concept of componendo and dividendo. Now suppose we have two ratios A over B and P over Q, and these two ratios are equal to each other. So when we have A over B is equal to P over Q, then the concept of componendo and dividendo, it says that we should have A plus B over A minus B is equal to P plus Q divided by P minus Q, right? So here we are not going into the detail of this result, but we'll use it directly, right? So here we are given this equation. So the numerator, it constitutes that is A, right? And the denominator is B, and here we have 5, and 5 can be written as 5 over 1, right? So we can take P by Q as 5 over 1. So let us apply this rule to this equation, right? So we have A over B is equal to P over Q. So we have A plus B. So a is square root of 1 plus x square plus square root of 1 minus x square, and b is square root of 1 plus x square minus square root of 1 minus x square, right? So now we have a plus b. So a plus b is square root of 1 plus x square plus square root of 1 minus x square. This is a. Then we have plus b. B is the denominator. We have square root of 1 plus x square minus square root of 1 minus x square. And in the denominator, we have square root of 1 plus x square plus square root of 1 minus x square. Then here we have the negative sign, and then we have this term square root of 1 plus x square minus square root of 1 minus x square. And in the right hand side we have 5 over 1, so we can write p plus q, that is the sum of p and q. Here we have 5 and 1, so we have 5 plus 1. Here we have 5 minus 1, right? So now see, in the numerator, these two terms get cancelled because this is negative sign, this is positive, and these two get added. So we have 2 times square root of 1 plus x square, and in the denominator, see here, when we multiply these two terms by this negative sign, here we have the positive sign, so we have minus plus minus. So this term and this term get cancelled, and minus becomes here positive. So we have a square root of 1 minus x square plus square root of 1 minus x square. So this is 2 times square root of 1 minus x square, and here we have 5 plus 1 6, here we have 5 minus 1 4, right? So this 2 and this 2 get cancelled, and here we have 2 3s are 6, this is 2 times 2 4. So now we have square root of 1 plus x square divided by square root of 1 minus x square is equal to 3 over 2. So now let us make the square of both sides so that we can get rid of this square root sign. So we have 1 plus x square, here we have 1 minus x square, and here we have 3 by 2 whole square, right? So now we have 1 plus x square over 1 minus x square. This is 9 over 4, right? Now multiplying 1 plus x square by 4 and 1 minus x square by 9 like this, that is cross multiplication. So we have 4 times 1 plus x square, and here we have 9 times 1 minus x square. So this is 4 plus 4x square, and here we have 9 minus 9x square. So let us rearrange the terms here. So we have 4x square taking minus 9x square to the left hand side. So this is plus 9x square. And here we have 9 minus 4. So taking 4 to the right hand side. So now we have 9 plus 4 is 13x square. And here we have 9 minus 4, that is 5. Right? So now we have a quadratic equation here, that is 13x square minus 5 is equal to 0. So this is a quadratic equation, right? So now writing x square as 5 over 13 and taking the square root of both sides, we have plus minus square root of 5 over 13, right? So the value of x is given by plus minus square root of 5 over 13, right? So here's the solution of this equation, which reduces to the quadratic equation with the help of this concept, that is componendo and dividendo. The value of x is given by plus minus square root of 5 over 13.